Okay, welcome back. On to problem 2. Here I just wanted to show um, one of the many ways that acronym I introduced can break down. The LIAT, LIAT, I don't know how to pronounce it. The one I introduced in the previous video, LIAT, right? This is one of the many ways. It's not the best. Let's go ahead and test out choosing u as the exponential versus u as the trigonometric function. Remember, the sole point of these kinds of integration by parts was to perform the DI method twice. That way we get back the same function as our I. We get back the same integral. And that can happen for both the exponential and the trigonometric function. So let's take a look. Let's go ahead and set u equal to the exponential first, right? So we have e to the 2x and sine of x. Differentiate, we get 2 e to the 2x, and we get 4 e to the 2x, plus minus plus. Integral of sine is negative cosine. Integral negative cosine is negative sine. Boom, we're back at the same function, so all we have to do is multiply, and then the product of these two is going to be our I, right? So what do we get? We get e to the 2x. That's a minus e to the 2x cosine x. Minus minus makes a plus 2e to the 2x sine x. And then we get a minus 4i integral of e to the 2x sine x. And this whole thing was initially equal to I. So all we have to do is solve for I, and we get that I is equal to all this junk divided by 5. So 1/5 to the negative 2x cosine x plus 2 e to the 2x sine x. And there we go. Now let's see what happens when we set d equal to sine of x. And you'll make the decision for yourself what you think is easier, if you prefer one over the other, or if you think they're about the same difficulty. At the end of the day, you solve problems at whatever pace and whatever technique you like. So these types of things are really subjective most of the time. But at the end of the day, solving tricky problems is if you've came across a problem like that before, or you're just very creative. So I'll stop yapping, and we'll set d to be sine of x. So d is sine of x. I is e to the 2x. Integral of e to the 2x is 1/2 e to the 2x, and then 1/4 e to the 2x. And then derivative of sine is cosine, and then derivative of cosine is negative sine. Okay, plus, minus, plus, multiply, multiply, multiply. We get 1/2 sine x e to the 2x minus 1/4 cosine x e to the 2x minus 1/4 I, right? And this whole thing is equal to I. So if we add 1/4 I, both sides, we get 5/4 I. So the final solution is multiply both sides by 4/5, right? And that simplifies to 2/5 e to the 2x sine x minus 1/5. Yep, e to the 2x cosine x. And let's go ahead and compare solutions. When we distribute this 1/5, what do we get? That's the same. When we distribute here, we get 2/5 e to the 2x. Yeah, they're exactly the same. And this specific problem, I would say they're both of equal difficulty. I don't see too many people saying one is more difficult than the other, but yeah, it's problems like these and more more tedious problems in the future where having an acronym is not really going to help you. And yeah, so that should motivate you to solve more problems and get more experience and build that muscle for yourself. Take care.